Drew.
Hey man, how you doing?
Yeah, fine, thanks. You?
Like this week has been a total. It's recording, isn't it? This week has been great. This week has been quite something with the incident that we've got ongoing, and I'm tired. And I mean, I haven't even looked at this talk. So the last time I looked at it, I'm really sorry. The last time I looked at this talk was about a month ago. And I was hoping to get some prep time today, but we've been fighting fires for like a week solid, and I haven't had a chance.
Please, Andrew, you know this. You got this.
Yeah, okay. Well, let's see how we do. Let's load it. I was just trying to find it. Here we go. Okay, and I'll just turn off my share my screen. Is it coming up? There we go. Oh. What?
It was coming up.
It was. There we go. Hey, there's back. Cool. So like this actually started off as a talk for Monitorama, and I dropped it, and it stopped being a talk for Monitorama, and it kind of was sitting around, and I was talking to Marin the other day, and we were discussing like how to do metrics on GitLab.com, and I was talking about the general metrics that we've got, and they've been around for about 6 months. I use them a lot, but generally in the company, they're not really used very much. And I think the main problem is a lot of people don't really understand them. But certainly in the last week, they've been the kind of primary signal that things are really slow. And so a lot of the other metrics that we have, haven't been alerting. We don't see a lot of alerts saying GitLab is really slow at the moment. And these alerts have been alerting. And so Marin suggested I give I give you guys a practice run of my talk that I did that was on the original subject. So I probably don't need to show you guys this, but this is obviously our architecture as it was about a year ago. And it's obviously changed a bit since then, but you guys probably have a better understanding of the original target audience. And I'm not sure if you're aware of this, excuse the terrible graphic, because this never got into being done. But this is what our monitoring infrastructure looks like. I just remembered that you can't really use an Apple mouse with Google Slides. It's like jumps around like crazy. So do you guys know how our monitoring infrastructure works?
I don't.
If you don't, I can also link you the recording I did the other day with Skarbek and Jarv, and it has like the details of what you see right here, but in talking form rather.
Yeah. I mean that was done after. So this is actually before that, and I was trying to find some time to look at what they did, because So what we have is we've obviously got Grafana. We've got two Grafanas. We've got dashboards GitLab Net and dashboards GitLab.com. And obviously what we don't want to do is have the public-facing Grafana kind of crash our infrastructure if there's like a Hacker News article or something like that. And so we have this little thing called Trickster, and Trickster is quite a clever little proxy that sits between the Prometheus infrastructure and Grafana. And what it does is it does a whole bunch of caching, but it does something else that's really clever. So if you ask for like a time series from Grafana, it'll look from now, like now being like the number of milliseconds after right now, and then it will look back every 30 seconds or whatever, going back in time. And that isn't very cacheable, because if I send you the link and you look at it, you're going to look at it like 1.5 seconds later, and then you're going to get a whole bunch of different data, which is like really stupid. And so what Trickster does, it goes, I'll give you sort of what you want, and it nudges everyone's time series so that they align, right? So if you're looking at now, and I'm looking at now, we kind of round down to the nearest minute so that we all get the same time series, and that's much more cacheable than like everyone having a slightly different skew. And I actually think we should probably put this on our private instance as well, particularly because it's a bit slow at the moment. And, you know, I'm never really that worried about the last 15 seconds. Like, it's really up to the last minute that we really care. So we might as well align on those things. So anyway, Trickster's there, and that goes into a thing called Thanos. And Thanos is kind of like a view onto lots of, well, Thanos does lots of different things, but in this context, Thanos query is a view onto lots of underlying Prometheus servers. So if you go to, you know, we have Prometheus-app, Prometheus-db, we've got Prometheus, and they're all collecting different metrics. And sometimes it's much more useful to just have a single view of those. And Thanos will effectively, when you make a query to Thanos, it'll fan those out. It'll query all the underlying Prometheus instances, get back the results, and then present you with a single view. So it's a much better sort of way of accessing Prometheus. It's especially useful for if you want to have the same dashboard and then just be able to pull down, like, the environment is prod or staging. You know, you don't have to change the data source for that, and that's really, really useful. So we've got Thanos, and then we've got lots of different Prometheus servers. And I've just lost my headphones because they have run out of battery. Give me a second. Can you hear me? Okay, cool. Hopefully I can hear you. No, let's just check what.
Can you hear us?
Yes, I can. Okay, cool. So yeah, so that's kind of what we've got on that. Oh yeah, and then the last thing it's got is we've got this thing called Thanos Compact and Thanos Store. And what they're doing is they take all the data from Prometheus and they're writing it to Google Cloud Storage buckets. And so if you look for something over the last week, it'll generally go on Prometheus. But if you're looking for data in Prometheus over like an 8-week period, it'll go off to the GCS buckets, and it will fetch it from there. And one of the things that Thanos Compactor does is it also aggregates it down to like an hour interval. So that's, instead of like looking at every 15 seconds, you get a new metric, it's just looking at an hour so that you can get like a longer time series. So that's like a super brief overview of what the metrics infrastructure looks like at the moment. So like, and this is just for the talk, but really what we were seeing like last year, or at least in 2017, was, you know, we had really bad availability on GitLab.com, kind of like feels like how the last week has been actually. You know, things were going down a lot. And the worst part is that it's not that we don't have enough metrics, right? We've got lots and lots and lots and lots of metrics, but it's not, that on its own isn't going to solve anything. So you can have lots of metrics, but if you're not using them properly, then they're not really helpful. Another kind of irony, which still exists, obviously this was kind of polished up for Monitorama talk, where it's sort of like, hey, everything's great now, but I think this is still like a major problem. And the other problem is that not only did we not have a lot of metrics, we also had a lot of alerts. But the alerts that we've got, especially in the production channel, if you go look in there and in PagerDuty, they're just firing all the time and nobody seems to be bothered about them. But, you know, if you look at the AppDex scores over the last week and the performance slowdowns, we're not getting alerts on that. We're getting alerts on very specific like production issues, which may or may not be critical, but we're not getting alerts on like what the users are being impacted by. So the way that people talk about this is our alerting is based on like causal alerts. So it's like, this is the cause of this, and here's an alert for that. The CPU on like Gitaly 05 is at 98%. It's a cause. But
you're basically trying to fix someone's broken leg while they're actually dying, right? Like you're focusing on broken leg instead of,
Exactly, yeah. And I mean, so really what this is about instead of using causal alerts, we're going to go to like symptom-based alerts, right? So it's like, what is the user experiencing? And we're gonna monitor that instead of saying, you know, like, hey, this is broken and fix it. So yeah, and we still have like all these alerts, and every time something goes wrong, we'll quickly go and like add another alert to Prometheus, and we'll say like, well, when this goes above this threshold, then we'll set another alert. And then of course, like if you look at the way GitLab works, everything's growing and growing and growing. And so, you know, I think there's one of the alerts says if we have 60 errors in Rails in a 1 minute period, then we need to send out an alert. Now, if you look at when that came about, it made sense because 60 was like a reasonable number. But if you look at like the 3,000 or 4,000 requests per second now, like 60 is like nothing, right? And so we just have this like whack-a-mole where we like stick an alert on it, and that's going to fix it for next time. And so we have all of these alerts that are firing that don't mean anything, and we're kind of ignoring them because they're just a little bit irritating. And we're playing whack-a-mole, and that's why there's a mole. We're just sort of hitting this, and then another one pops up, and we hit that one. And so we you know, even with all of these alerts, we still have, you know, they're not kind of forewarning us of problems. Like often the first time we really know that things are going wrong is when someone goes into the production channel and says, hey guys, have you seen that there's the Tanuki on GitLab.com? And actually I was talking to someone this morning, and it was like the way we seem to treat things is like, no Tanuki, no problem. It's like if someone comes in and goes, hey, there's a Tanuki on the page, and it's like, okay, everyone scrambles. But, you know, if you've got like 5 seconds latency on every single web request, this sort of attitude is like, well, you know, we don't see a Tanuki yet, everything's fine. And like, it's the wrong way of looking at things. So like, I was trying to like model what our metrics look like at the moment. So we have all of these metrics coming in, and then we'll create a bunch of recording rules, and those recording rules will get consumed by dashboards, and then some of the recording rules will get consumed by alerts. But the problem is, like, often what happens is the dashboards actually stop working, or maybe we change the configuration of the dashboard. And so like a lot of the recording rules don't seem to actually be there for any purpose other than they were there as an optimization for a dashboard that was around like 5 years ago that nobody actually uses anymore. And same with the alerts. We might actually remove the alert, but we don't remove the recording rules. So we have this whole sort of like rabbit's warren, like also rat's nest of like things that are wired together, and it's pretty chaotic. Like, I don't know if you've ever tried to sort of audit the alerting rules that we have in the Runbooks project. It's like a little bit crazy. And like what's actually even worse about this is that if you go look through our dashboards, like most of our dashboards don't work. Like I would say more than 50% of our dashboards, they're just empty. And like, when did they stop working? Nobody knows. What's actually more scary than that is the same is true for our alerts, right? Because Prometheus has got like a very clever and very sophisticated alerting system compared to many other alerting systems that are out there. And it gives you an expression. And if the expression sort of resolves to data, then you have an alert, and it fires really well. But the problem is that the reason why the alert doesn't resolve to data might be because it's false, like the expression hasn't been met, but it also could be because the actual underlying data has like long been removed from the system, right? And so you can't tell the two. So I would guess that maybe 25 or 30% of the alerts that we have in our runbooks haven't seen any data for like the last year. Like they're just there giving us like this false sense of security. Oh, we have an alert for that. There's no way to actually, well, there is a way. You have to manually go and look at that alert and sort of decompose it and look for the underlying series and make sure that they're there. But nobody does that. There's no CI for that. And so we have this like big problem where we have like a lot of alerts that don't mean anything. We have a lot of dashboards that don't work. And so like what I was trying to do with the general metrics was to try to like sort of reset the board a little bit and kind of come up with something a little bit more sane. And so I came up with this idea of building like a pipeline where we have alerts coming in and then we apply the same steps to all of the alerts. And then what we can say is like, we sort of normalize all alerts down. So for every service that we have on GitLab, we say, we want to have an error rate, a single error rate metric for that service. We want to have a single appdex for that service. We want to have a single availability, and we want to have a single operation rate per second, like how many operations are going in. And those are the 4 that we've kind of picked on. And I'm very close to adding a 5th one, which is saturation. And so what saturation is it kind of depends on the service. But if you think about it, like the saturation of Postgres, one of the saturation parameters for Postgres would be, in Postgres, we can have 100 concurrent connections into the Postgres server at any one time. We are currently sitting at 70. So the saturation level would be 70. PG Bouncer is the same thing. We have lots of, and for Unicorn, the saturation would be, we have 1,000 Unicorn workers. And so far at the moment, we're using like 700 of them. And so we have these different, like saturation is different for each kind of service, but effectively, and each service would have multiple saturation parameters. Like another one that would be common across all services is the CPU on that service, right? And then the aggregate saturation of the service isn't the average of like the CPU and the connection pool size, it's the max. So whatever the most saturated underlying metric is, that's your saturation. So sorry, I spun off on the saturation, but what we're trying to do is come up with like a simple set of key metrics. So we just want like a few ways to tell the health of a service instead of 1,000 ways that we can't keep track of. And so like with this, the whole plan is like we tame our pipeline and we can tell when things are broken. We can have like a small set of dashboards that we can kind of use to look at all of our services and kind of tame everything and have a single set of alerts and a single set of dashboards. And the results are promising because like this stuff is really working and I feel very confident in it. So obviously, like what I wanted to do with this was the goals of the project were to reduce the outages, like the problems that we're seeing, like as we see at the moment, and then trying to get an early warning onto issues. And then I really wanted this to be like system-wide. So like, this isn't about like individual teams like losing their dashboards. Like we will still always have like a PG Bouncer dashboard or a Redis dashboard that's got all sorts of minutiae about the way Redis works or about its particular metrics. But this is about like having like a overall view of the system and being able to say like Redis is healthy right now, Gitaly is healthy right now, the web is healthy, but API is not. Like we need to zoom in on the API. And then maybe at that point you go down to the more detailed dashboards. And so it's like a high level view, as the application gets more complicated, like, we can't have like every single ops person being like an expert in every single component. And so this is just like, we have the same set of health metrics for each service. And then we just know at a high level whether or not they work. And so like, this is the main dashboard for a service. And, these are the 4 things that I was talking about. So we've got like Appdex, and Appdex is sometimes I think it's a little bit complicated for people to understand because it's not a latency. It's like, it's a percentage of your requests that come into that service that are satisfied within an acceptable amount of time, right? So what's really nice about that compared to latency is that you can give me an aptX for any service, and I don't need to know whether it is good. Like if you give me a latency, if you say like this service, like if you say Redis is responding to requests in 100 milliseconds, you need to know that whether that's good or bad in terms of Redis. And that's like, not everyone knows that. I know Redis very well. And I know like if Redis is taking 100 milliseconds to respond, like your system's going to be totally down and flat. But not everyone knows that. And the nice thing about aptX is that all you have to say is that the aptX score for Redis is like 99%. That's fine. Like maybe 1% of requests are a little bit slow. But then Gitterly, you know, it's like, oh, well, a second is probably okay for some Gitterly calls. So it'll have a totally different aptX, but the range, totally different latency, but the aptXs will be on the same level. And so because we're converting it from a time in milliseconds to a ratio, we can compare all of the different aptXs for all of our services and come up with a single value. And we can then start talking about the SLO for aptX. We can say, well, for Gitterly, we want it to be that 99.9% of requests come within a satisfactory period. The other thing about aptX that's really, really powerful is that if you want to say like, you know, some requests, like a garbage collection request, we literally don't care how long it takes. It could take, like some garbage collection requests in Gitterly take half an hour, and we don't want those requests to kind of mess up the whole thing. So the aptX score for Gitterly specifically excludes garbage collection, right? Because we just ignore it. We just throw it out, and we don't count that as part of our aptX score. But obviously for other things, we do. Another example of that is on the API, we have long polling requests that come in that nearly always take 50 seconds. So if you look at the P99 value or the P95 value for our API requests in Workhorse, it's a flat line. It's 50 seconds. And if you look at it, you're like, oh, there's something wrong with our metrics. But actually, because we have these long polling requests that always take 50 seconds, it makes perfect sense. And so for the aptX score for the API, we actually specifically exclude like long polling requests because they don't give you anything useful. And so that's another reason why using aptX rather than P95 is a much more powerful measure. And then error ratios is basically just like the number of requests, the number of errors that you see in a minute divided by the number of requests in a minute. And the reason we use a ratio is exactly the same reason, because, you know, talking about 60 errors in a minute doesn't make any sense. You know, if it's 60 errors in a minute and there were 100 requests, well, that's pretty bad. But if 60 errors in the minute and there was 10,000 requests, like who cares? And so again, it's about like taking your raw data and putting it into like into a ratio. Availability is the same. Again, it's a ratio, but this time it's a ratio of how many services that are supposed to be serving that process are running versus the number that are available. So like if you got lots of server restarts or like hangs or something like that, that will dip down. Or like during a deploy, we always see that go down and back up. And it's the way we calculate that is super easy because Prometheus actually gives us to you built in. Prometheus has a metric called up. And every time it tries to scrape a server, if it can't get hold of the server, it sets up to 0. And so all you have to do is basically figure out the ratio of the number of servers serving, say, the web or the API or Gitterly or whatever, and you say like, well, you know, 90% of them are up. Now, at the moment, we don't have SLOs on that, but like what I would like to see in future is that we actually have quite a low, like 75% SLO, because we should always have enough redundancy that we can take like a hit in our availability, and then it shouldn't matter. Like, you know, if a single, like at the moment, if a single web node hangs, we have like lots of alerting going on. Like to me, like in an ideal world, like that machine should just be destroyed and a new one created like automatically. Like, who cares? Like everything's going to fail, and having failing nodes is not a problem. It's only when you get to like critical redundancy that it's a problem. Now, obviously, with single points of failure like Gitterly, it would be much higher. But for the web, we should have it low, and we shouldn't be alerting on like a web machine or an API machine crashing, because our redundancy should handle that. And then the last one is the operations per second, or like RPS is like request per second. And that's the only one that is actually a metric in its real form, right? So the others are all ratios, and this one is an actual number. And that's because you can't really represent it in the form of a ratio, because if you look at something like Gitterly, we're doing about 5,000 RPS across the Gitterly fleet. If you look at Postgres, we're doing like 80,000 RPS. And so they're different numbers, but there's actually something that we do, which is that we measure the Z-score. And if I've got time at the end of this, I'll show that to you, because I'm really, really happy with that. And I presented about it at Monitorama, and there were lots of people that were like, that's a good idea. So I'll show you that. So, okay, I've kind of explained all of these, so we can just move on. And then I've already described aptX to you on the last slide, so we'll just move on from that as well. So like the pipeline that we use on GitLab.com with these metrics is, first thing we do is we collect the metrics. And then for each service, we kind of adapt the metrics and put them into the pipeline, and we aggregate them into specific ways. So like, for example, collection is pretty much, let me just check what the next slide is. Yeah, okay, so I'll explain this more. So there's basically 4 steps, and this is kind of just the overview. The first step is we collect the metrics, and that's exactly as we do at the moment. There's no difference there. We just collect them into Prometheus. Then the second step is where we normalize the metrics, and we turn them into like aptX scores and error ratios and availability ratios, and we aggregate them, and that's super important. So when a metric comes into the system, it has like an arbitrary number of labels on it, right? So it might have like the name of the host, the name of the gRPC method, like the status of the gRPC call afterwards, or the HTTP code. So it might be like 401, 402, 403, 404. And the problem with that is that with all of those, you sort of have like an unbounded set of metrics on your data. And so it's very difficult to automate things unless you aggregate it down to like a limited set. And that's one of the things we did, and that's really important in this whole thing. Then once we've got that, we can start building up statistics, and we can do anomaly detection, because we have like a finite set of dimensions, and we can sort of look over those. And then finally, with that, we can build alerts and dashboards that sort of reuse the same metrics, and I'll show you that as well. So this is just, sorry, don't use Apple Mouse with Google Spreadsheets or Google Slides. So like, this is just another explanation of what I was talking about on the last page. So we have all of the normal exporters coming in, and one of the things I really like about this approach is that we don't need to like rebuild our application metrics, or we don't need to say, okay, we're going to fork HA proxy exporter and make it support aptX now, because like ain't nobody got time for that. So what we'd rather do is we take the existing exporters and we adapt them to our system, and we have like a whole bunch of recording rules that we use to take the existing metrics and turn them into what we need. And so the recording rules will do the aptX, it does the error rates, it does the request per second, and I left off the availability, but that we also do. And then using the error rate and the request per rate, we figure out the error ratio, which is obviously just the one divided by the other. And then from that, we can start building up alerts. So we build up an alert for the SLO, the error ratio, and then we also have a warning for when that says aptX ratio anomaly warning. Sorry, that actually we don't do that anymore. The the request per second anomaly warning we use as well, but these two warnings over here we don't actually use anymore, because I've learned a little bit more about statistics and I figured out that that's wrong. But I'll talk about that a bit more later. So like this is probably all a little bit confusing at the moment. Oh, we've run out of time already. Sorry. How much time do you guys have?
So maybe not go into details of explaining like everything about this.
Yeah.
I have 15 more minutes. I don't know about others.
Yeah. I'll run through really quickly.
I'm
okay.
fine.
Okay, cool. So like what we have is we have like, you know, this is what we have coming in for one of our services, right? And we just have this like raw metric. And then what we do with the recording rules is we take it and we'll eventually convert it into this metric. So this is, as you can see here, this has got like a whole bunch of like arbitrary dimensions on it, and it's really hard. And then what we have here is like a metric with a fixed set of dimensions. It's like the dimensions are super simple. It's like it's this environment, it's this service. So we use type to represent service in our world, but it's basically, think of it as service. And then what we have now as a dimension is stage. And so what that means is we can compare canary to not canary, right, in the same environments. And so we can say, what is the apdex of our canary versus what is the apdex of our production environments? And we can also say, what's our canary versus an hour ago before we did the deploy? Is it in a worse state? Are we seeing a high error ratio? And we have all of those metrics now. So yeah, this is just kind of explaining how we kind of turn it down. So what's important is that for each service, we have a specific metric to turn it, sorry, a specific recording rule to turn it into the, like the apdex and the error rate and the way that we implement that is like per service. And so this was trying to show an example of how we take the HA proxy for canary, or for not for canary, for our non-canary environments, and turn that into an apdex score. And this rule is very specific to this environment and this. And so what we get out at the end is like a nice clean metric like that, and we can kind of just look at those sort of together. And then this is just about statistics. So once we've got the metrics, we can start doing very clever things, like we can look at the standard deviation and the mean for the statistic, and then that's what we can start using to do anomaly detection, right? Because if you have a normally distributed metric, like, you know, if you pick a value now, where does it lie? Well, it's the chances are, like if you look at requests per second, it's a classic example of a normally distributed metric. And so like you will find that about 68% of your values will lie one standard deviation either side of your mean, right? And then 95% will lie within two standard deviations. It's also called a Z-score. So if you take a value and you say, how far is this from the mean? That if you measure that in standard deviations, that's called a Z-score. And then within 3 standard deviations, you get about 99.7%. So that's what we use to do anomaly detection. And I've got a whole talk on this, so I won't go into too much, but that's how we can kind of spot these outliers, and I did alerting on it. It turns out that some of our metrics are not actually normally distributed, and so that's why I've stopped using it for the error ratio and the apdex score. But our request per second rates are normally distributed, so I've carried on using it. And then I don't know if you've got time to go into this, but this is how we do the anomaly detection on request per second. But basically, we use the seasonality in the data. So what we see is that like week in and week out, we have the same values. And so using that, we predict where it should lie. And I'm not going to go into it now, but like this is basically a whole talk about like how we kind of do it. And I can give you a link to the Monitorama talk, because I actually did a much better job at explaining all of this in the Monitorama talk, and it's quite short. So Anyway, and then finally, once we've got all of this data in this format, I'm just going to quickly log into here. We can go to so what it means is that we have the data that we're collecting for each service. We can plot it on like a single set of dashboards, and this is this triage dashboard that I use, right? And so for all of our services, we plot our apdexes alongside one another here, and we plot our error ratios, our requests per second, and our availability. And so what's really nice here is that we've kind of brought like lots and lots and lots of different data, and we've kind of nudged it down so that it's all the same. And so we can compare like with like. So when something goes really wrong, it's really obvious because, you know, all the values are the same. As I said earlier, the only one we don't do that with is the request service per second, because it's not really possible. But what we can do with request per second is we can basically plot how unusual that value is for this time of day, right? So we can say, well, it's a Thursday afternoon, and so this request should be very high, but actually it's like twice as high as it should be, and so this is called the Z-score. So if I go over the last 7 days, you'll see, let's take a look at this. So what is this? So this service over here has been acting very unusually. What is that? That is...
Looks like Git, right? Or Sidekick.
Yeah, Git, maybe 0.1, minus 0.1. I mean, Redis as well. So like if you go look here, if we zoom in on this, you'll see like this. So you can see here, this is the graph. If we're kind of comparing the request per second rate for all of our services, you can't really see like a big, sorry about the birds. You can't really see like much detail in here. Like it's not, but when you compare like the standard deviations, you can see, hey, wait a minute, this is a very unusual value. Like Redis was spiking up there, but you know, when you look at it on here, it's not really clear. And so when these values go like into the red, that's when we start sending out alerts on them. And we've got built-in alerting for all of this stuff. I feel like I've spoken a lot at you guys. So if we've got like 7 minutes left, then I'll let you ask questions and maybe help you understand it. I do feel like this has been super rushed. So like, yeah.
Let's go for questions, if you have any.
Well, I'm not sure if this is related, but we have an alerts general channel on Slack. So
yes.
The alerts you were mentioning are those that are like being displayed every, I don't know how many minutes on that channel?
Yes. Yeah, so that channel's kind of still, there's several alerts that go in there, right? So one of them is like, if you go into, like each of these services here has its own dashboard, like here, and I'll explain the alerts that go into there. Service platform metrics. So there's a whole bunch of different alerts that go in there, and some of them are like more important than others. But the alerts that go in there are all like on a per service level. And so the really important ones are, I'm just going to zoom in on a little bit of this graph over here. So like the first one that we see, which is the one that's been firing for the last week nonstop, is the SLO on the apdex score is below. So for each of our services, we have a service level objective. And so what we say is we would like to achieve like that 99% of our web requests come in within the allotted thresholds for a web request, right? And what you can see, that dotted line over there is that SLO, it's that target represented on a graph. And the yellow line is the actual value. So when that actual value is underneath the target, that's when you, for 5 minutes, that's when you get an alert, right? The same goes for the error ratio. So these are the SLO targets. And so here you can see our actual error rate is 0.01%, but our target error rate is 0.5%. So we haven't been getting alerts on that. If you zoom, last 7 days, you can see here, like during this period over here, now this turned out to be kind of like what happened was we enabled a bunch of machines and then we turned them off, but we didn't turn them off fully. And so they were health checking and erroring and they were like in a bad state. And so here we got a very clear signal that something was wrong, and we could fix it. What's quite nice with the SLOs is that each service has a different level. So if you go to Italy, right, this is 0.5%, but the SLO for Italy is trimmed much closer to, so for Italy, the SLO is 0.1%, right? So it's a much lower SLO. And what I'd like to see over time is that we keep trimming these down. It's effectively a recording rule. The SLO is a recording rule that says SLO, Italy, error rate, and it's just a fixed value, 0.5. So most recording rules are like a Prometheus expression, and these recording rules are just a fixed value. So if you want to adjust it up or down, you just go make a merge request, and that value will go up or down, and then automatically any service that exceeds its SLO will automatically fire an alert. It's not like we've wired together one alert for Italy and one alert for the web and one for the API. Just the fact that the API is generating an error ratio metric, you'll automatically get this. So that's the first, those are the two SLO alerts, right? So those are, when you see SLO, those are the ones that I'm listening to the most. One of the things that's important to realize is that those SLO alerts, because we break everything down by stage now, and we have the canary stage and the main stage, a lot of the SLO alerts that are firing at the moment are for the canary stage. And we don't have canary Italy, obviously. So if we go to canary web, what we find is that it's a little bit more, it's a little bit more jerky at the moment. And so like, I don't think we'll route those to PagerDuty yet. But when I see in that channel, I see like SLO alerts, like this service main stage, then I'm like, okay, like things have gone wrong. And that's when I start reacting. And that's why I really feel those actually need to go to PagerDuty now. We had a meeting on Tuesday, and we agreed that those actually now like need to fire like and get people out of bed, because generally when they go wrong, it means that there's a real problem. The availability, I haven't got the representation on here, but at the moment for all services, this is fixed at 75%. These are probably easier to understand if I turn off the deploy annotations. So these are all fixed basically at this level here. And I think what I need to do as the next step is adjust it in the same way that each service has a aptX and an error ratio SLO. We have an availability SLO. Then the last type of alert that we get in that channel, actually there's several more types, but one of the last is when this, so this is our prediction for what this metric should be like, the request per second for this service at this time of day on this day of the week, right? So what we find with our data is that it's for the request per second data, it's very, very seasonal. So we see exactly the same. If you look at our data, we'll have this little hump, which is European lunchtime, where we see a little hump and then the Americans come online, see that, and on Fridays, we see the same slope off week in, week out, week in, week out. And every week we just have the same gradual growth. And this green line actually takes the green growth, the growth into account, and then it looks at like 3 weeks worth of data, and that whole anomaly detection talk that I was mentioning is about that. The problem at the moment is because we've chopped our Prometheus down to 1 week's retention, I've only got 1 week's worth of data to guess this. And so it's not as good as it was like a month ago. And I'm pushing to get us the Prometheus data back, but that's another question. So the next type of alert that we get is that this line jumps outside of the green boundary, then we can then we alert on that. But I don't think that will ever go to PagerDuty, because what's better is that we build services that can handle traffic spikes. So, you know, at the moment, if you go to Pages is the one that gets the most traffic spikes. And so let's just look. The dotted line, by the way, is what was happening last week. It's not totally, so let's just look over. Yeah, right. So like if we go take a look at this spike over here in Pages, you know, you can see that is what we were expecting the range to be. And then now that on its own shouldn't get someone out of bed, right? But over here, you can see what that did to the SLO, because Pages sort of faints at the drop of a hat when it gets any traffic. That just led to a massive spike in errors. And so because the error rate went over the Pages SLO, someone would have got paged for that. So then they would have woken up. In an ideal world, they would have come to this page and they would see like, hey, like, look at this. Like the reason is because of this anomaly here in that. And so we have an alert that goes to Slack, but I don't think that'll ever go to PagerDuty. Another thing that's kind of worth pointing out is that for Pages, we don't have an AppDex score. And that's that because at the moment, we don't have the data, right? And so like what's quite nice about this is we can optionally put things in. One of the nice things about this approach is that because the recording rule can be based on anything, for some services, we actually use like HA proxy data to figure out, like for the registry, the error rate that we use actually comes from HA proxy. And so we kind of adapt the HA proxy data and make it the error rate for the registry service. And so, you know, if you go look at the registry, and I think it's the same for Pages, but we're still missing some data. So this, like, the registry doesn't emit an error rate value, but we've kind of, because of the flexibility of the recording rules, we've used this instead. Sorry, I'm just talking like again. So did that answer your question?
Yes, thank you.
Cool. Are there any other questions? Does it make sense or?
Yeah, this makes a lot of sense. I really like this. I think you should be part of the onboarding for engineering, this recording, because it's really helpful. And the other things is that I really love that you said is you finally explained me why when I go through the Grafana, most of the dashboards are empty. And I always asking myself, is something really bad happening or I'm just looking at the wrong thing?
Yeah.
So I think this is a very good starting point for understanding what's going on, because all the other dashboards, or you know what to expect in the dashboards, or you can't use them because they are too complex or too baked into the details. You have to be an expert, not only of the thing that you're looking at, but also at how the matrix was built. So
yeah. So one of the things that I didn't touch on was that I also have alerts that tell me when I'm not getting alert data anymore. And because we have a fixed expectation of what all the metric data is, we can alert on it not being there. And so in a deployment recently, we lost, sorry, maybe it's back now. We lost all of our Sidekick data. And here, oh, it's back. Okay, so no, that's kind of weird.
Andrew, I need to
Yeah.
drop off.
Sorry.
Just wanted to give you a highlight to Alessio and Mayra before I leave, and you can continue if you want to. The reason, I don't know if you realize by now, but the reason why I ask you to be present and try to understand this is you're not SREs, you're not holding a pager. It's not your job to necessarily like jump on all of these alerts. What is your job though is to help out the SREs once they finally get to understand what's happening and where they're looking at. And I want you to be the ones also to understand, you know, in case there is something like this happening, how to like consume this data. And also if at any point in time you get like a bit of free time to try and teach yourselves on like, hey, I'm noticing that this is a problem. I'm going to improve the product itself so that it can actually help out the SREs understand what's happening a bit better. So that's the angle of why the two of you are in this. Andrew, thank you so much for doing this. I really, really appreciate it. I learned a lot still from it. So I'm going to put this on YouTube if you don't mind. If you mind, send me a message, and I won't, I guess. I need to drop off, so I'll catch you all later. Bye.
You are muted, Andrew.
Ah, there we go. Just want to quickly show you, if you want to, so the other thing I've been doing is I've stopped using like Grafana to edit dashboards, because it's like a horrible way, and you like everyone's overriding one another, and nobody knows like why a change was made or why dashboards stopped working. And so now, like all the dashboards that I'm building, I'm putting into Grafana itself, into the Runbooks repository, and it uses this thing called JSONet. And JSONet is like a JSON templating library that Google built, and they use it for a lot of stuff. And so imagine like JSON with functions, right? And so you could say like, instead of having like a hash, you just say, get the value of this hash from this function. And then the guys from the Grafana team have built something called Graphonet, which is basically Grafana library for JSONet. And what that means is that all my dashboards are in here, and it's not just horrible Grafana JSON. It's kind of like a little bit like kind of ordered. And so, you know, I've got all my alerts in here, and I can do all of that. And then the thing that I love about this approach is like, maybe you didn't notice, maybe you did, but like all my dashboards have got the same like colors and everything. And if I want to change the color, I go to that function, that thing, and I change the color for critical things is that. And I change that, I commit my change, it automatically deploys it to Grafana, and all the dashboards have got like the new color. Like the color for critical is X. And like I do that with a bunch of stuff, and it's like a much better way of doing this. So if you want to contribute to that, or if you like want to add new dashboards, like this is how I'm trying to do this. You'll actually see these dashboards, if you try to edit them, they're not editable. I mean, you can override that, but yeah, anyway. Cool. I think that's it for me, unless you got any more questions.
No, I have no other questions. So thank you for your time for explaining this.
Yeah, cool. My pleasure.
Yeah, this was awesome. Thank you.
I just remember one more. Okay, awesome. Yeah, awesome. I'll show you some. There's one other thing with this error budget that I'd like to show you at some stage, but I can show it to you another time. It's basically this over here is a recording of how much time we're spending underneath the SLO for that thing, and so we can start sending attribution to teams and saying, you know, the Gitterly service is, you know, not reaching its error budget. In fact, the Gitterly service is pretty good, but you know, we now have that metric, and we can compare different services to their SLOs and say whether or not they're any good.
Yeah, they have a good error. Yeah, they're good badges because the attribution is easier there. It's a separate service, but if you want to go in the web or API and then attribute to manage or verify,
that's the hard thing. Yeah. Anyway, cool. Okay, thanks, guys. Have a good rest of your day.
You too. Bye. Thank you again.